Alright, in this problem, two protons traveling in the two different directions. One is towards the positive x direction, and another is that towards in the negative x direction with the same speed, which is magnitude of this speed is 2 into 10 to the 7 meter per second. Now we have to find out the Lorentz force on the upper proton. That means this one. Say if I write for the simplicity, say I'm saying that this is the proton 1 and say this is the proton 2. We have to find out that the Lorentz force on the proton 2. So that we know that the Lorentz force actually that sum of that electrostatic force and that magnetic force, right? So we can write down the Lorentz force, which is FL, would be sum of this electrostatic force plus that magnetic force. Find electrostatic force on this two proton. We can find out, they give me that formula, right? What would be that electrostatic force? So that should be that Q divided by R square into J hat, because if I draw that I'm going to draw this electrostatic force on that proton will be towards that direction. They will repel each other, right? I should write, so this is would be that electrostatic force. Fine. Then we can find out that magnitude. So this is going to be because I know that the R basically that 1 centimeter that's given, which is 1 into 10 to the minus 2 meter. Then we can find out this electrostatic force on the upper proton provided by the lower proton P1, so which would be 9 into 10 to the power 9, which is the Coulomb constant, into 1.6 into 10 to the power minus 19 square divided by 1 into 10 to the power minus 2 square, which is the distance between these two protons, and J hat. If you solve this one, you will find out that the electrostatic force on the proton 2 provided by the proton 1 would be 2.304 into 10 to the power minus 24 J hat Newton. So that means it should be towards the Y direction. This would be that electrostatic force on the proton 2. Fine. Now I have to find out that magnetic force. Now the magnetic force which is going to be created by this P1, we can write in a form that formula, which is magnetic force Fm is on the charge Q2, right? Then the speed of the V2 into the magnetic field at the location of the charge Q2. So that means there will be a magnetic field at the location of this proton 2, which will be created by this proton P1. So that's why I'm writing that magnetic field is at the location of the 2 provided by the proton 1. So this will be the magnetic force on the proton P2. Fine. Now I have to find out this V21, the magnetic field on the proton 2 provided by the 1. We can find out using the Biot-Savart law, which is actually that mu naught divided by 4 pi the proton 1, which is q1, you can write down also. So this is actually the q1 into speed of the proton 1, which is the v1, into r hat divided by r square, which is the r between that distance over here, right? So this is actually that r. We can also modify this is one more line, so we can write, so this is actually that mu naught divided by 4 pi into q1 into v1 cross r divided by r cube, right? Because we defined that r hat actually that vector r divided by magnitude of r. Now over here this vector r I can write, which is basically that 1 centimeter, right? That's given, and this is towards the positive y direction. Then I should write this vector r would be 1 into 10 to the power minus 2 j hat, right? And the magnitude of this one would be same, which is I can write into 0.01 meter, and the v1, which is towards the positive x direction, that I can write is 2 into 10 to the power 7 I hat meter per second, right? Is towards that direction, towards the positive x direction. Fine. Using that information, we can find out that B21, so that magnetic field at the location of the proton 2 created by the proton 1 would be, I can write is a 4 pi into 10 to the power minus 7 divided by 4 pi. Then the magnitude of the charge, which is actually 1.6 into 10 to the power minus 19. Magnitude of the charge q1, which is the proton 1. If it is electron, I will use the negative sign over there. Fine. Into v1. v1 actually the 2 into 10 to the power 7 I hat into r1, which is 1 into 10 to the power minus 2 j hat divided by r cube. So r cube is basically 0.01 meter cube. If you solve, you will find out that this B21 will be 3 point, because this you can do some calculation, you can cancel out, you will find out this 10 to the 7 will be 10 plus 10 to the 7 will be cancelled out. In that case, I'll find out it would be 3.2 into 10 to the power minus 15 into I hat cross j hat, right? And you can find out that this one would be basically I cross j is going to be that plus k. You can use that trigonometric identity. Basically is going to be the 3.2 into 10 to the power minus 15 k hat. This is actually that magnetic field at the location of the proton 2 created by the proton 1. So that's when I can draw this magnetic field. So I'm using the different color of this magnetic field, which would be basically towards that positive k direction. This is actually that direction of magnetic field B21, which is basically towards the z direction. You can also use the right hand rule to find out that one, right? To find out the direction of this magnetic field. Put your finger in the direction of that direction. Put your index finger toward that direction and keep your palm towards that second direction, which is the R, in that direction. Then if you rotate your index finger towards the second vector R, then your thumb would be basically towards that Z direction. So that's why that magnetic field will be towards that Z direction. This is actually that figure over here, that magnetic field. Fine, this is actually the resultant figure. I'm going to draw that one. Fine. Now, what would be in the case that now I'm going to find out that magnetic force on that proton 2 provided by the proton 1 is going to be Q2 V2 into B21 I find out, and V2, which is the charge of this proton 2 towards the negative x direction, I should write 2 into 10 to the power 7 minus I hat, right, meter per second. That I know that everything. I can find out that magnetic force in that case. What would be that? I should write charge, which is 1.6 into 10 to the power minus 19, right? This is the charge of the proton. And the B2, for that one I'm going to use the curly bracket over here, minus 2 into 10 to the power 7 I hat. I drop that unit, cross magnetic field B21, which is 3.2 into 10 to the power minus 15 K hat, right? Fine. Then I can write magnetic force on the proton 2 created by the proton 1. What would be that? If you do that, I'll find out there is a minus sign. I factor out that one. It should be minus 1.024 into 10 to the power minus 26 I cross K. This is the vector quantity. Now I cross K would be basically that minus J. You can find out this is I, J and K. If you move to the counterclockwise, it will be the positive. If you move to the clockwise, there should be the negative. Then I cross K, I'm moving to the clockwise, right? So I cross K would be basically that minus J. So then I'll find out this Fm would be minus 1.024 into 10 to the minus 26 would be that minus J hat. And this minus is going to be basically the plus. I'll find out this Fm would be basically the plus 1.024 into 10 to the power minus 26 J hat Newton. So that's mean your magnetic force on the proton 2 created by the proton 1 will be towards the positive y direction. This is the direction of this magnetic field. This is actually this magnetic field, which is strength basically the lower. I'm sorry, this is actually the electrostatic force, which is the strength is higher, right? So this is the magnetic electrostatic force. This is actually the magnetic force. They use that FB instead of FM. I use that FM. They use that FB. Anyway, but you can also use the right rule to find out that direction of this FM, right? How? You can put your index finger towards the speed. You can put your index finger towards that direction, right? Then keep your palm towards that magnetic field, that direction, right? Put your index finger towards the B, that's mean toward that direction. Sorry. Keep your index finger toward that direction and keep your palm towards that magnetic field. Then if you rotate that index finger from first vector to the second vector, that's mean toward that direction, you will find out your thumb would be towards that upward direction. Your thumb would be towards that direction, positive y direction. So that's why your magnetic force would be also towards that y direction. Fine. Now what would be that Lorentz force? Lorentz force is basically sum of these two, right? Then now we can write that total force, or the Lorentz force, which is actually that FL. We can write electrostatic force plus that magnetic force. They are in the same direction. I'm going to add them over here, right? If they are in the different direction, I'm going to subtract them. So what is that? The electrostatic force is 2.304 into 10 to the power minus 24 J hat, plus the magnetic force is 1.024 into 10 to the power minus 26 J hat. Magnetic force is lower than that electrostatic force. Then your resultant force is going to be 2.314 into 10 to the power minus 24 J hat Newton. So that is actually that Lorentz force over here. This is the answer of this question. Okay, thank you very much.